Hey Mohammed, how you doing today?
Hey Zach, doing well. It's been a while, hasn't it?
Years.
Uh, so what are we doing today?
Today you are going to teach me how to do test-driven development using
Hmm.
pytest.
Yep. Okay. So let's get to it. So what are we gonna? So to do a test, you need something to test, right? So what are we gonna test exactly?
So I think it would be helpful to have a rolling mean function to take a pandas data frame and identify a particular column and calculate the a rolling average for that column and append that as a new column to the data frame.
Okay. So implementation wise, we will have a function. Let's call it what? What's a good name?
Rolling average.
Calculate rolling average,
Yeah.
I guess. Yeah. Okay. So let's start to do some implementation. I see you already have a Python script open.
So what should we do first?
Yeah. Import pandas. Okay. And then now we define the function name. And then what input should it get?
So we're going to want to input a data frame,
Right. I think so too.
which I think we can call df.
Yeah. Good call there using typing to annotate the function. But I think that's not the right way to call a data frame. I think it's just data frame in one word. PD data frame.
I think you're right.
Yeah.
Yep. Okay.
And then what? The column name?
So we're going to want a column name, which is going to be a string, I suppose.
Yeah, makes sense.
So we're going to need to know the window size for the rolling average,
Hmm.
which presumably will be an int.
Right.
And then we should also, well, if we're going to have this function always calculate a mean, I suppose we don't need to tell it the particular function we want to operate on, right?
That's true. Yeah.
So, and then we
Then let's.
we want to return a pandas series.
Right.
Can I
Oh,
ask a question?
yes.
I used underscore here, but is proper Python convention to do camel case?
No, in Python, the convention is not to use camel case. Okay, one sec. Let me recall the convention. So when defining a class in Python, the convention is to use camel case. But when defining a function, the convention is to, if you have a long name, you separate them with underscore.
Okay.
Mhm.
Just wanted to make sure we were following proper convention.
Awesome. So now, wait. So the idea behind test-driven development is that you you begin by writing a test that fails. Okay. And before that, we know that before you can even write a test, you need to have something that to test, right? So now we already have that something to test. So if like you're a hardcore TDD person, what you would do next is to skip the implementation for now. So in Python, we'll just put a pass statement here. Okay, and then now we think about how do we write the test. So we're gonna be focusing on writing tests using pytest. So in pytest, the convention is to start with a file called test underscore the module name.
So we'll create a new file.
Mhm. And wait, since we're trying to get familiar with Bash, right? Let me show you how to create files in using Bash. So if you open the terminal, to create an empty file, you just call touch.
Touch.
Yes. And then the file name.
And it will be a .py file.
Yes.
Okay.
You have to supply the extension too. And C.
There we go.
Yep.
It's like magic.
Sure is. Okay. So of course, the first thing we need to do is to import pytest. And then import that feature engineering module. And since we only have one function to test, and for brevity's sake, maybe we can do from feature engineering import that function name. Yeah. Okay. Then the next thing is to define the test function.
So if we're going to do this, we're also going to need to import pandas then, right? Because that's not going to come from that function.
Yes, we will need to define test cases using pandas. So yeah, we do need pandas too. Yes. Well spotted.
That's what I'm here for.
Okay, so creating the test function. The convention here is that you start a function that's meant to test something with the word test. So, and then underscore the name of the test. So in our case, it will be test underscore calculate moving average. Well, you forgot the def.
Oh, whoops.
And then, yeah, we can leave the argument empty now. And then just put a pass statement first. Okay, before we continue, some best practices. This part here, this test calculate rolling average, that should be something that's descriptive, such that if the test fails, you'll see that function name and you know why it failed. And so you can imagine a case where maybe you have you create a class. It's a very complicated class that does many different things, and you may be tempted to write a function called def test underscore class X, and in that test you test all the possible things your class can do. The problem with that approach is that if one of the assertions fail, you're not really sure why it failed. It's better to create a function called test class A underscore what exactly you're testing, what part. Maybe it's a data scraping part or an API call part of the class.
Okay.
Okay. As we create a more complex project, we'll start to see this pattern become more valuable. Sorry, not pattern, practice. Okay. So now before we write the test, let's just make sure that we have set things up correctly. Let's see what happens if we run pytest in the command line. And let's see, no test run, test session start, root directory, pytest example. Okay, maybe instead of pass, you write assert true.
You know what? I don't know that I had saved the file. Could that be why?
You saved it because I can see in the file name, the tab there, there's no like a circle that shows it's unsaved.
Yeah, I just saved it.
Oh, okay. Oh, okay. Then try again.
There we go.
Yes. Okay. All right. So now let's talk about implementing the test. So step one is to define the input and the expected output. So as we mentioned, the input to that calculate running function will be three things, right?
So we're going to
data
have
frame.
this information right here.
Right.
Should we include that same information
In the argument?
as an argument?
We should, as a best practice, because what we will do is that we will pass the same function, the rolling function, with different kinds of input. For example, first we may test it with a legit, data frame that has numbers in it and the column names. And then maybe as another test case is that we will test it with an empty data frame and see what happens to the function.
Okay.
But since we're just starting out, we'll keep things simple and we'll just focus on one case, which is the case where we have a legit data frame and the column exists, that kind of things.
Okay.
So for now, we'll just define the inputs as part of the function body.
Okay. So how would we go about doing that?
So I would say create a variable named testdf and then define a data frame with any column name and then some random numbers in it. Make sure those are easy numbers for us to manually calculate the moving average.
Oh gosh, good point.
Okay, and then let's create another variable called for the column name, and then have it be my nums.
Whoops, I'm guessing it should be test call name.
It's not a requirement, but it's a good naming convention to follow.
Okay.
And then the last one would be the test window size variable.
And here we can
This
just
would be
pick a number, maybe 2.
2. Okay. And then now we should define the expected output.
I'm sorry, do what?
Define the expected output.
Okay.
So define a variable named expected output. And then this would be a data frame. Or I think it should be a series. What did we define earlier in the feature engineering module?
We had said that it would be a series.
Yes, okay.
And
So for a series, we can just pass a list of numbers, right?
Does it need a name?
It doesn't,
Okay.
as far as I know.
Oh.
But yeah, I haven't been using pandas for almost a year already, so. Okay. So yeah.
Now we have to do some math.
Yes.
So
Excel.
this brings up a good point so now we need to know how the rolling average, what do we want for the numbers before we hit the window size? So for the first number, if we have a window size of 2, the first number I'm guessing we should leave the same.
Okay. Yeah. Okay.
the second
Do
number.
we don't really? I don't think so, because then it will be misleading. If the
So
first two numbers are not actual moving average, I think it should be NA, or like not a number kind of thing.
sure.
Uh,
So in this case,
1
the
plus
average
1
of
divided by 2,
yeah,
right?
which is going to be
It's
1.
1.
So now we have 1 plus 2, which would be 3 divided by 2, which is 1.5. And then we'll have 2.5.
2.5, yeah. Okay. I hope it's right.
Let's hope we can average two numbers together.
Yeah.
And this is a good example too because the data type is switching from an integer to a float.
Yes. Yes, exactly. Okay. And then the next thing is to define the actual output.
Okay. Prior to doing that, I just want to run this whole thing.
Uh-huh.
Okay. I just wanted to make sure that you could name it, that you didn't have to name it if it was a series. Okay.
Okay. And yep, so define a variable called actual output. And this would be a function of that calculate rolling average.
With our test df.
Uh-huh. As call name and window size.
Okay.
So we expect the actual output to be a PyTest series. Now that we have the actual output and the expected output, then we can do a comparison whether they match our expectations. I'm not sure it's just as simple as just doing an equal comparison. What do you think?
I'm guessing we need some sort of assert statement.
Yeah, definitely an assert. But then is assert expected output equals actual output enough? I don't think so. But let's try to create another data. Let's try to create two series in the REPL and try to see what happens if we do that equal comparison.
Actually, I think I can.
Oh,
I was hoping.
what's up?
I was hoping I had saved it
Oh.
already. But I'd copied something else. Okay, so that's going to do an element-wise comparison. And
Okay.
it looks like the NaN compared to the NaN is false by default. Which
That
is interesting.
So weird, yeah.
So I believe there is an assert specific to data frames.
Yes. Let's pull up the docs for pandas. Or we can try to. I don't know how familiar are you with the API of pandas.
Yeah.
It might be faster to try it in the REPL or Google it.
I think we should Google it.
Okay. Wow, they've revamped the website. API reference. So, yeah.
Do you think?
Yeah, sir. That's a good starting point. Yeah. So apparently, yep, that's what we want. Click that and
Sorry, 1 second. I just see another pandas testing assert underscore assert is equal. Okay, that's the same thing as this. Okay, just making sure.
So left and right, check data types true. Oh, that's so convenient.
Um,
Yeah, hmm?
let's see if there's anything it says about missing values.
Okay. Check index type, check series type, check less precise, check names, check exact, check category order, check frequency, check flags, tolerance, object, check index. Nope. Huh. And the test doesn't have an A example. The code snippet. Let's try it.
So
But before that, we should test it with the series example to check whether the NP9 is equal. You didn't remove the equal.
oops, good catch.
True. Yes, it's true. Can you just to double check that the behavior is that if it's okay, it won't flag anything. Can you just modify one element of that list, of that series?
Yes.
Okay, cool.
Oh, it gives you a pretty detailed
Yep.
answer.
Thank you, Pandas developers.
Yeah. So, what was interesting in this case, because we didn't name our column, I wonder if we're going to have to make use of that argument to check name. It defaults to true. And so I suspect that it will not work unless we switch this to false.
But by default, do Pandas series have names?
No, but the
Our function, so
oh,
in line 13,
our function doesn't have a name either. Okay.
yeah,
I see, never mind.
okay. So usually when we write a test, we end it with an assert statement. But since we have a utility function in Pandas that checks every single detail of the series, we use that function. We end it with that function instead. Okay. So the next step in TDD is to run this test. So if we go back to the terminal, bash, and we run it.
Let me save it this time. I can imagine spending hours trying to troubleshoot because you didn't save the file.
Okay, so as expected, it failed. And let's scroll up from the beginning. Okay, so test calculate rolling average. So it writes the test function. Okay, scroll down. Okay, and then see it. Oh, you didn't write. It's just point a few lines before the failure. So the failure happened there. And then if we look at the reason, not the reason, but the analysis, why is that check instance there? I don't know, but okay. Where is expected type found instead? So series expected type class pandas, but found none type instead. Does this make sense?
It does, because our function right now just passes, and so nothing is returned.
Right. So then the next step of TDD is to actually implement the function. But before that, I'm curious to see why is that actual output have a squiggly line. Is that some kind of syntax error? Can you just hover over there? Assigning result of a function call.
Oh, the function has no return.
Oh, not yet.
I think VS Code is against TDD.
Well, in hindsight, you should have also, if you go back to the feature engineering. So yeah, in hindsight, we shouldn't have put a pass statement because by default it will return a none. This conflicts with our implementation, which says that it should return a series. So what we should have done is to return an empty series. So just for fun, let's try to do that now. Return an empty series and see how does that change the failure. Yeah, just leave it like that and then save it.
Okay, we'll come down here and we'll run pytest again.
Mm-hmm. Okay, so yeah, much better warning or failure message. Series lengths are different. The left is 4 and then the right is 0.
Very specific information.
Mm-hmm. So now we can get back to the implementation.
Okay. So to implement this can actually be a one-liner.
Okay.
So we can leave the return there. And then what we're going to do is we are going to use Panda's built-in rolling function. So our result may look something like this, where we take the data frame, pick out a particular column, which will be column name, and then run the rolling method on that series.
Mm-hmm.
We use the window size that we have the user input, and then we want our particular function to take the mean, and so we'll do that.
Okay. This looks like a reasonable implementation to me. I think it's correct.
My gut is questioning what is the default behavior for missing values with mean.
I think it's not a value,
Okay.
not a number. Yeah.
So hopefully that works as we want.
Mm-hmm. So save it and then test it.
Okay, we'll come down here, we'll run pytest.
Data frame object has no attribute column name.
Exactly as we planned. Okay. So
you scroll up too far. I think this was a previous run.
no. Oh, short test summary.
Data frame object has no attribute column name. It seems to me to mean that the column name doesn't exist. My name, did you put my name? Test column name is my nums. And the data frame also has my nums there. Should work. Maybe before this is like a very quick and dirty way to debug a function. Just put a print statement of the data frame and see what columns does it have before the call to return. I mean, in a new line. print the data frame.
Oh, just the data frame?
Yeah.
And then,
Save it and then run the test.
ah.
So my nums is there. You can see that in the section my captured standard out call, but it's still saying the data frame has no attribute call name. Ah, yeah, because the call name is a string. Yeah, you can't do this with a variable. You can't use this dot notation to call a column name. You have to use that yeah, the square bracket thing.
Yep.
Okay, this time it should work. Unless our maths is wrong.
Be careful saying that. We should be able to get rid of this too, right? I guess we can leave it. It doesn't hurt anything.
Yeah. Oh my god, the name is different. Oh.
Yeah,
Okay.
so this is what I was talking about, right?
So if you create a series of a data frames column, the series will have the name of that column. Okay. Well, how important is a series name for our use case? I don't think it is. So rather than creating a test input with the name, so rather than having the expected output have a name, we can just disable the check when we call the function, the set function to check the series. So, oh, I thought we can look at the, no, we can look at the pop-up, but yeah, this works too.
Sorry, say what you were thinking.
We don't have to go to the documentation. We can look at the pop-up when you type the function argument. Did you notice that?
Just right here, yeah.
Yeah, so if you can scroll down and see check names. Okay.
Why don't you say it one more time for good luck? This time will work.
Still work.
Hey!
Boom. Right. So to recap, the idea behind test-driven development is that first you define your function's interface or slash signature. So in this case, we define the function name and the inputs and the output it should return. And then the next step is to then write a test function for that function that will fail. And then after that, you go back to your function definition and then implement it.